All right, this is a continuation of the urinary system lecture. In this mini lecture, we're going to cover the anatomy of the urinary system to help us get set up to understand the physiology. Now, if you've already taken anatomy, almost all of this will be review for you. And of course, this is not an anatomy class, so this will be anatomy light, L-I-T-E. All right, from a gross perspective, meaning large perspective, the urinary system is pretty simple. The two major organs that are involved in the urinary system are a right and left kidney. So those are here. You know that from anatomy, you know that they tend to be a little bit more dorsal or posterior rather than anterior, so they're towards the back. You may also recall, just from looking at blood vessel flow, that the arteries that lead into the kidneys are really large. So the renal arteries coming off the abdominal aorta are some of the first arteries to branch off, and they're large. So because they're large, a lot of blood flow gets diverted into them. And in fact, at rest, those small little kidneys can receive up to 20% of your cardiac output, which I think is huge. So let's go ahead and put that down. So the kidneys clearly are going to be getting a lot of blood. Okay, so what else do we have? Well, the kidneys are involved in basically taking blood, filtering it out, dumping a bunch of stuff that we want to keep back into the blood, and then taking the leftover and dumping it down the drain. And that drain is going to be the ureters. So you have two ureters, one that leads from each kidney. There's one, there's the other, those are the drains. And of course, then the urine gets stored in the bladder. And the bladder, of course, will expand until you feel the need to urinate. So the purpose of the bladder is predominantly just to store urine so that you're not dribbling every 5 minutes or so, which would be embarrassing. But it also serves an evolutionary advantage because, as any of you who have dogs are aware of, dogs have a great sense of smell for other types of urine, including the urine of other dogs. So if you're a predator and you're chasing an animal, if they're leaving a urine trail for you, it's basically X marks the spot. Just follow the urine and you'll find the bunny or whatever prey animal you're looking for. So bladders probably evolved as a defense mechanism so that all the urine could be dumped out in one spot and then they could run away without leaving a trail to their location. So bladders serve that purpose, and of course in today's society it's more of when your bladder fails you, it's more embarrassing than anything. Okay, when urine comes out, it comes out the urethra. So we are going to be spending all of our time looking at the kidneys. When we take a look at a cross-section of a kidney, it doesn't look terribly interesting. I don't know if any of you guys saw this in the anatomy for the cadavers, but when you open up the kidneys, you can see some of the major structures, but it doesn't look that fascinating. So we're not really going to get into the various parts. What I want you to understand is that the functional unit of the kidney is something called a nephron. And there are about 1 million nephrons in each kidney. So the nephron is the functional unit of the kidney. So you can think of the kidney as basically a collection of these nephrons. So how does this work? Okay, the kidney basically takes blood, filters out some of the fluid from the blood. So remember, the fluid component of the blood is plasma. So all of the cellular elements are left alone. Some of the fluid component comes out, and then that fluid component is going to have all the stuff dissolved in plasma, minus a lot of the plasma proteins for reasons we'll get into. So that's, what does the plasma have? It has water, it has nutrients, it has waste products, it has ions, it has hormones, it has small plasma proteins in it. So those are all things that are going to be in the plasma. So that all comes out, or most of that comes out, And then, of course, you want to keep most of it. You want to keep most of your water. You want to keep certainly all of your nutrients. You might even want to keep some of your waste products. I mean, technically bicarbonate is a waste product, but you don't want to get rid of all of that, because if you did, you would lose one of your major systems that help buffer the pH. So you may even want to keep some of your waste products. So you basically go through and kind of recollect, nope, I want that water, nope, I want that nutrient, nope, I want that, nope, I want that. And whatever is left over gets dumped down these calyxes that are here, and then that is all urine. So once the fluid reaches these points in here, you have reached urine. And of course, then that urine is going to drain down the ureter. All right, I liken this to a scene from Finding Nemo, if any of you are familiar with that movie. When I teach this urinary system in a 100 level, I teach it like Finding Nemo. I start by explaining, there's a fish tank and all the fish are in it and they're trying to make it really gunky. I don't know if you guys remember that scene, so that it will be super, super gunky, and the dentist will have to clean out the fish tank and take the fish out. Well, what does the dentist do? The dentist gets a new type of filtration system instead. And the filtration system is one that sits over the end of the aquarium and basically is constantly sucking up aquarium water and running it through a filter. So it sucks up aquarium water, runs it through a filter, and dumps most of the clean water back, and then any of the gunk gets stuck on the filter. Kidneys are kind of similar. Kidneys are constantly pulling blood, looking at the blood, screening the blood, dumps most of the stuff back into the blood, and then the gunk goes down as waste. So let's come back to that idea of a nephron. The functional unit of the kidney is a nephron. So I'm going to go ahead and draw out a nephron for you. And you guys should try drawing this as well. And then we're going to go ahead and label the parts. Okay, so here I have drawn the various parts of the nephron. So now I'm going to type out the names of the various structures, and what we're going to do is try to match them to this drawing. Okay, So here's a list of terms that we need to know associated with the nephron. So the first thing that you guys might notice is that there is a clear loop in this structure. So that loop is the loop of Henle. So that area from here to here is all the loop of Henle. Now, part of that loop of Henle is called the ascending loop of Henle, and the other part is called the descending loop of Henle. So which one is which? Well, you know that to descend means to go down, and to ascend means to come up. So if we understand which direction fluid moves, then we should know which one is down and which one is up. So fluid is going to be moving in this direction through the nephron. So if we know that, then the descending loop of Henle is going to be this region over here. And that means the ascending loop of Henle is the other part. Okay, so when we take a look at the nephron, you might see something that looks a little bit like a capsule. And so that's actually called Bowman's capsule, and that region is going to be over here. So that's all Bowman's capsule. Now, Bowman's capsule encapsulates a capillary bed, and that capillary bed is the glomerulus. So Bowman's capsule encapsulates the glomerulus. So we can name both of those. Okay, so we covered Bowman's capsule and the glomerulus. So fluid is actually going to start as blood. So we will start with blood here. So blood comes in, enters this glomerulus, and then some of the fluid actually gets filtered out into the structure, the tubular structure that is the nephron. So blood is going to move into the glomerulus and then get filtered out, at least the liquid part will get filtered out and captured in the early part of this nephron. So that early part of the nephron is called the proximal tubule. And you guys might be familiar with the term proximal from anatomy. It means close to. So it's close to the blood. And so this first section from the Bowman's capsule until you start going down the loop of Henle is called the proximal tubule. Okay, so you might notice that there is a distal tubule. The distal tubule is more distant, farther away. So the region that is the distal tubule is over here. Okay, if we go back to this idea of fluid flow, we started with blood. The blood, of course, is going to give up some of its fluid, and that fluid is going to enter the nephron. The fluid is going to move down the proximal tubule. Then it's going to move down the descending loop of Henle, the ascending loop of Henle, the distal tubule. Now, all along the way, it's not just taking a joyride. It's not just having a fun trip through the nephron. During each of these tubes or tubules, there's processes that are happening. And most of those processes are about reabsorbing what you filtered out. So you filtered out part of the blood, and then what you're going to do is you're actually going to recapture much of what's actually in the proximal tubule and some of what's in the loop of Henle, and then some of what's in the distal tubule. So what are you recapturing? The stuff you want to keep. Water, your nutrients, your salts, a lot of your salts, maybe even some of your waste products. So by the time you get down here, there's not that much fluid left actually. And so the fluid that is left goes down and becomes urine. So we call this final tubule the collecting duct because it's collecting the leftovers to become urine. Okay, so now that we've covered the anatomy of the nephron, let's take another look at it. So this image here on the left is showing something kind of similar to what I drew. You should be able to identify Bowman's capsule, the proximal tubule, the descending loop of Henle, the ascending loop of Henle, the distal tubule, and the collecting duct. So let's briefly do that. Bowman's capsule, proximal tubule, descending loop of Henle, ascending loop of Henle, distal tubule, collecting duct. Okay, notice that I have the phrase unfolded nephron. Nephrons do not normally look stretched out like that. Rather, if you look at a real nephron, it's folded in on itself. So let's actually trace it on the right picture. So we have here Bowman's capsule. You can see the glomerulus is inside. Proximal tubule, descending loop of Henle. Now, what we would expect is that the ascending loop of Henle would go this way, but notice it goes the other way instead. Ascending loop of Henle comes back around and seems to split those two blood vessels that we see right over here. Interesting. That structure that consists of those two blood vessels and the ascending loop of Henle where they kind of make a complex is called the juxtaglomerular apparatus, and it serves a couple different purposes, some of which we will be looking at in later lectures. So this is the juxtaglomerular apparatus. It's these two blood vessels here that we have not yet named, and the ascending loop of Henle as it transitions into the distal tubule. So remember that term, we'll be coming back to it. So following this, we have our ascending loop of Henle, and then of course now we're going to go into the distal tubule, and then finally into our collecting duct. Now you might notice that the loops of Henle, the proximal tubule, and the distal tubule seem to be covered in these additional capillaries. Those are called the peritubular capillaries. Peri means like around or on the outside or by, so peritubular means around the tubes. So I'll use a different color to show all the peritubular capillaries. It's all of this stuff here. Those are all the peritubular capillaries. Okay, so there are actually two capillary beds associated with a nephron. So this is highly unusual. I actually want to come back here and talk a little bit about this two capillary bed system. So typically, when we have blood flow, we know that blood goes from arteries into arterioles, then an arteriole will lead into a capillary bed, so fluid will move into a capillary bed, and then from a capillary bed it will go into a venule, and then into a series of progressively bigger venules until it finally gets into veins. And those are the vessels that blood moves through in that order. there are a couple of exceptions in the body. And the exceptions are when blood actually moves through two capillary beds kind of right behind each other. They usually serve some sort of purpose, and this nephron is one of those examples, and there's of course a purpose for it. We call those systems where you move through two capillary beds in tandem portals. So these are called portal systems. So in a portal system, you go through the first capillary bed, and then you get funneled into a second arteriole. That will then lead into a second capillary bed. And from the second capillary bed, then finally you'll go into the venule and the veins. Okay, so we see a portal system here. So let's name what we see. All right, we have blood that is coming in to an arteriole, and I'm drawing it with an arrow there. So that is called the afferent arteriole. So we've seen the term afferent and efferent with the neurons. Afferent brings information to the central nervous system. Efferent takes information away from the central nervous system. So we're going to apply those same terms here. Afferent means to bring to, efferent means to take away. So an afferent arteriole is basically bringing blood to the glomerulus. That's our first capillary bed. And then blood is coming away in that second arteriole. That's going to be the efferent arteriole. There's my efferent arteriole. And it's going to go into a second capillary bed. Well, that second capillary bed is the peritubular capillaries. So if we come back over here, let's go ahead and put these names down into our portal system. So we have the afferent arteriole, leading into the glomerulus. So remember, the glomerulus is the capillary bed that is encapsulated by Bowman's capsule. Some of the blood is going to leave via the efferent arteriole. And then the efferent arteriole is going to open back up into a second capillary bed that surrounds a lot of the tubules, including the proximal tubule, the loop of Henle, and the distal tubule. And that second capillary bed is the peritubular capillaries. So that's where we are for anatomy. I'm going to come back down over here real quick. And on this drawing, we can also label, this is the afferent arteriole. So just put AA for afferent arteriole. And then over here, that's our efferent arteriole. And the peritubular capillaries are not shown on this diagram. Okay, so now that we've finished our discussion of the anatomy of the nephron, let's start talking about processes. So there are 4 major processes associated with the nephron, or things that are occurring as part of the nephron's function. They are filtration, reabsorption, secretion, and excretion.